client's futures contracts, but he'd have like a 90% chance of success
All
in
right.
that system, and
It
he would just
is
make money on corn all the time.
Time for some data science.
Woo!
My co-organizer, Cheermeister, will be a little more active now. Casey face. And I'm Michael DuPont. We're both the core organizers of Orlando Machine Learning and Data Science. We live stream everything, so hello everyone on the live stream. If you miss an event or if you want to go back and see past events, they're all available on YouTube at Orlando Machine Learning and Data Science, or actually just Orlando MLDS, but if you search for that, it'll be one of the first things that comes up. I know we had a lot of people I would say a healthy majority, probably 80% people here for the first time, so that's awesome. Spark definitely brings a lot of people out. So, quick note, Orlando PyCon is coming up. I also run the Orlando Python meetup group as well. We have a beginner series going on right now. It's a 3-parter. We had the first one 2 weeks ago. 3 weeks ago? Weeks are weird. You can watch that on YouTube as well. It's the most recent video until this one gets posted. And we went through just getting used to Python. The next meetup, we're going to take a quick look at functions and get into classes. One after that, we'll look at some third-party libraries, and hopefully, if you haven't looked at Python yet, you can come out to Orlando PyCon and be able to understand what's going on. Always fun when we have a lot of people coming out. So,
It's terrifying.
well, that's only, you're not the one speaking. So, this one we have Spark. Amelia Bennett is going to be giving a talk on Spark for everyone, and without me rambling any further,
Oh no, keep rambling.
I'm not a rambling man. I see the floor.
Hi. Yeah, this is seriously a dumpster fire. You can leave now if you want to. So yeah, Spark filled up the freaking room. Speaking of fires, there's probably a fire code issue. But yes, Apache Spark is a fast and general engine for big data processing. From that versus, Hadoop was hot, now Spark is hot. And if you dick around on KD Nuggets too long, I think now the Smart movie is slowly moving to Apache Arrow. But that's if you're one of those people that obsessively follows that. Why do we like Spark? Spark is fast. Woo! I'm getting like flares. Okay. It scales. You can parallelize it. Yeah. And you don't have to use Hadoop. So seriously, why did y'all show up? Somebody please speak.
I showed up because I want to know what Spark's all about. What he does.
You feed data in, you do a tremendous amount of cleaning, you get stuff out. Answer your question.
It's magic.
What?
It's magic.
It kind of is. I don't know. You define magic.
Anything where I don't have to understand what's going in the black box.
No, this isn't magic. This is me in a freaking French maid costume with a freaking shovel. Thank you for listening. Does anybody else have a particular reason for being here? Woo!
I just got a job as a data engineer, and they use Spark there, and I've only used it once before.
I love data engineers. They make my life easy.
You're welcome.
I'd like to know when not to use it.
Woo!
What are the don'ts? What's your stuff?
Yeah. How do we define big data?
Terabytes?
Right.
Okay, you think big data is terabytes?
It's relative.
It's relative. I don't know if Well, yeah, you could probably do terabytes in Spark. Name a use case where you would have terabytes that you would be running through this.
Just because it's what I'm into ad
Just
tech.
because.
Say you got clicks going from hundreds of clients who serve millions of people on their sites a day. You got to deal with all that data, and that's I think they said 13 to 14 terabytes a day they deal with.
But that can be aggregated right into something workable, right?
Yeah.
See, that would be you doing your job. Any other definitions of big
So
data?
are you suggesting Spark is not the tool to make that, take that
I'm
14 terabytes
suggesting-
down to a workable size? Or are you
I
saying
am
Spark
suggesting
is after?
Apache Drill might be something to look into for something that size, but and then go into Spark. But I'm suggesting that there are lots of people that break out Spark completely unnecessarily. So I'll give you an example from work. We were running things in Spark, and it was taking hours, and it turned out to actually be much faster to wind up doing it locally, even though it was only a 2 gigabyte data set. So there's that. There still isn't a good deep learning solution that distributes really well, at least not that I've seen. HTO is interesting. I've also taken, like, earlier today, I was screwing with this LFS thing, and it supposedly extends Keras, and I was on a TensorFlow on Spark project, like that's what's sitting in this freaking directory. And that does not go very well, but yeah, I don't know, you don't actually need all of this for most use cases. Yes, how many people here are regularly dealing with files bigger than 4 gigabytes? You are,
I mean,
okay. 1, 2,
I mean, our
3,
target is way higher than that for our use cases.
Apache Drill. So 1, 2, half a dozen? Okay, you all are not an interactive audience. Ooh, you raised your hand. Tell me about what you do.
Yeah, I'm the same company. So we'll be talking.
Oh yeah.
Thank you. So we are. So yeah, as you're saying, like, we are living in Aptic data. So like billions of impressions coming every day. We have a pipeline that we are processing all these billions of data. So each time we go to a website, right? So what kind of do so each time 3 or 4 days. So given that like all websites is like yes,
My hearing is really terrible, and I didn't get much opposed to what you said, but that's
Oh,
okay.
okay.
Don't worry about it.
Okay, what I'm saying is that we are dealing with Aptic data. So we are basically starting impressions when people go to websites. So it's like each of these arrival is considered an event, right? So each time someone is going to a website, if you're seeing a couple of places, array spaces, all of them could be an event. So it's like billions of events that we are covering every day. So
That's
it's like
gigabytes today.
It's like that data can't be filled, like you can't fit in the computer, right?
Don't worry about it.
TLDR was that they do like billions of clicks a day and it won't all fit in one person's computer.
Well, yeah. So Spark breaks into associated little things with it. So you have Spark ML, which is hand raised.
I just want to hear what your definition of big data is.
Anything that does not fit in memory on a single box. Right, so Spark gets into a bunch of different things. There is GraphX, which totally sucks, but the community has built Graph Frames, which is much nicer. There is one guy who was supposed to be here that would love GraphX, and he's not here, so shame on him. But there's that. There is RSpark, which gets used later in the presentation. There is SparkLur, which is another interface from Spark to R, or R to Spark, and that is actually a dumpster fire, but that's why we have Spark R. And Spark SQL is useful. Jesus. Yeah, there's that. Woo! We have tons and tons of goodies here. It's pleasantly, I don't know, you get good stuff here. Where's ML Lib? Here we go. What?
Could you zoom in? Command plus.
Oh, Command plus, okay. Boop, boop, boop. So, yeah, this is exciting because it has everything, and when you hear about something so big and very much in development, you don't think that it has all the things, and it turns out it has almost, well, unless you're one of those nitpicky people that really likes using R for proper statistics. Kathy, you're ignoring me.
Oh, sorry.
It's okay.
I was reading what's the difference between SAP HANA and Spark.
What is SAP HANA?
In memory database.
Okay. That was that oddball skill that made the top of the DICE salary survey, and everybody's looking at it wondering, like, what the frack is that? Yeah, okay.
Averages, yeah.
Right. Yeah, it's the only things that aren't currently working with this are deep learning, because go figure, TensorFlow on Spark that Yahoo produced at the end of last year, that is a dumpster fire. H2O kind of, sort of, deep water is. So for those of you, yeah, so this is something I've been screwing with on Kaggle, but this is not Spark, this is a Spark competitor. So eventually we're getting to a point of distributed deep learning. It's just very, very buggy and very, very hacky. And oh yeah, so you all can take notes. I don't know. I like to play with things that organically came up. I'm trying to read you, Michael, and your face says nothing. But yeah, so it's got that. You have your clustering. You have this is exciting. So it.
But then I have a question. So is Spark the database itself, or is it just a toolkit?
Brilliant question. Spark requires a database to operate.
Okay. So just a toolkit to see how you're storing. So
Okay.
it's a column based and a row based. And then you
So you have your database, and then you have Spark. Like with one of my home setups, because I'm a speed freak, I typically use Cassandra as the database versus a Hadoop database. Usually people wind up putting Spark on top of Hadoop, but you are not tied to it, not by a long shot. I'll pull up the Zeppelin page really quickly. So I have Zeppelin notebooks floating around, but yeah, Zeppelin which is integrated with Spark, goes with a whole bunch of things that are not just Hadoop, like probably Pentaho at some point, maybe. Already. You all are exciting.
So we see all these things that Spark can integrate with, and we've heard a lot about when not to use Spark and when to use other things like the Happy Drill. If you were to give an elevator pitch for why use Spark over something else, what would it be? And say, I know nothing. How would I use Spark to analyze a large distributed data set?
You want an elevator talk on that? Seriously? Seriously? That's intense, dude. Why?
I know that some people in the room are familiar with Spark, and I am sure that a number of people have also just only heard Spark and say, oh, it's this amazing tool, but I have no idea what it is.
It really just boils down to speed.
Speed to...
So, speed in dealing with data sets that are too big for memory. That's it. You're giving me the dead anthem.
So is this like you can search a data set faster, or you can reprocess it faster? Sorry, I'm
Process.
pretty much illiterate, so.
That's okay. No. Illiteracy is, yeah, you're not illiterate, but no, it's an amazing thing. Yeah, so Spark SQL actually does move pretty quickly, I think. I don't know, no, I can't touch any of that data here, but I don't know, I should have brought a demo with a massive data set, and I was just putting things things together so that I can run something through. But yeah, Spark SQL moves.
Could we work through a simple data set just to see how?
I've got one right here.
Okay, awesome.
Yeah, no, I remembered to put up something. So, okay, where else? Right, so that was, yeah, the trade-off is you have to deal with lazy evaluation and debugging help, and yeah, not everything. This is why I got really excited about moving stuff from Python to R, all with the Spark setup, is because you can go to R packages all in that Zeppelin notebook and start doing real interesting things. I will get to that in binary. Zeppelin notebooks, like Jupyter notebooks, deeply integrated with Spark. Yay! So,
What's a Zeppelin notebook?
Zeppelin notebook. I am showing you the Zeppelin notebook now. Woo! So let me blow this up. So in the interest of moving along quickly, I pulled this data set and just ran through a quick binary classification example, and we can throw anything at it. But once after this, there's also the Enron data I have sitting over here, which isn't quite where it needs to be, but we should be able to put out a model tonight. And I think this is a standalone cluster sitting with a GPU on it. So if we really get bored, there's Keras and TensorFlow sitting on here. So we'll see where things go. So let's see, this data set, so it's a census data from 1994, and all we're doing is predicting more than 50 grand a year, less than 50 grand a year. That's it, there's nothing terribly exciting here. So we're starting with R, and so this is your, who here has never read anything into R before?
Oh my god.
I am still puzzled as to like how it was that Orlando managed to have an R ladies group before any other R group. Like that's a neat trick.
We need to have a user R.
We do, but you already kind of like, I don't know.
Well, I guess data analysis, data science
But
is
see,
kind of not
ML&DS does they like completely ignore the stats here.
I guess you could take a survey why they're here then.
I tried that. I got death stares. Okay.
Okay, we'll have workshops for R users.
Maybe. So you're gonna lay that on me, and it's gonna be my problem. So we read it in. We have age. We have work class. We have. I have no idea what this variable is, but it's there. Education, marital status, blah 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 blah. Associated stuff from the 1994 census, and we're predicting income. So I wanted to pull this in with R, and just because I felt like playing around, I saved it out and brought it back in, all just nice and neat like that, back into PySpark. So we have that. Turns out I did not want to read it automatically, so I had to do a little bit of data cleanup with just recasting the variables as they need to be. This is where we get into something vaguely resembling excitement. There are pipelines. I like pipelines. I don't know if you all like pipelines, but I like pipelines. This is where Spark gets fast. Because of that lazy loading, you can stick all of this into one pipeline, and when you fire off the pipeline, it optimizes it. This matters versus some other tool where you're going through it bit by bit by bit. This is where you get a lot of that speed versus MapReduce. So this is, let's see. So we have our categorical columns, we have numeric columns. They have to be indexed when hot encoded. And then you have numeric columns going straight into vector assembler. I thought this was the weirdest thing. You have to put together features and then train it on something. This is foreign for someone who was into R since 2009. Yeah. What else? Where are we going? Vector assembler is tricky. It only takes, so must be double or, what are these other ones? Double, it also has to be indexed. Hey, I'm gonna cheat a little. Cheating's great. Set. It always takes this long when you're dealing with Spark, which is why I'm kind of slightly pushy about if it's a tiny data set, you don't. Okay, I get to run this fresh. Woo. Boom.
Just a really quick question while we're just waiting for this. So I'm having trouble figuring out where the R ends and the Spark really begins. Is it the pipelines? That's
It's all in the interpreter. Let me pull up the pile of interpreters that comes with Zeppelin with the base install. So there is Alluxio, whatever that is, Angular, BigQuery, Cassandra, Elasticsearch, File, Flink, HBase. They threw the whole kitchen sink in here. Well, maybe not the whole kitchen sink, but enough. And so you get down to the Spark interpreter. Spark default is Scala. There's PySpark, Python, and R right here. You just have to declare it up here. Good question. Okay, so did this run? Or yeah, very good. Very good. So boop. Boop. Okay. And now we get our pipeline. Once you, so comparing like, I don't know, time steps, if you don't put it into a pipeline versus what just happened, so I clocked this once with another data set. It was doing 8 minutes per index encoding step, multiplied out by 20 different variables. And when you put it on the pipeline, that chopped it down to, well, I think 15 grand total. So this is one of the delightful things with Spark. Woo!
I'm just a little confused about the notebook. Is this compiling code?
It's like a Jupyter notebook.
I still, I mean, I'm like Vim.
This is not Vim.
Yeah.
This is definitely not Vim. We do not compile.
No?
Yeah.
So a good explanation of this is, so it is like Jupyter notebooks. There are also a handful of other things like Databricks has something similar, Eager.io. What all these programs allow you to do is have code blocks, independently runnable code blocks. So if you know that you have your data pipeline is good, and you're now trying to run a independent section that you're trying to get right, just right, you could run that code block without having to run all of your pre-process, all the code that you've done before that you know works. And a lot of them, they allow you to at least mix Markdown. So you can actually have Markdown compatible comments around exactly what you're doing in each code block. And some, like I believe Zeppelin lets you do what I'm looking at, and Databricks and Eager.io allow you, and actually Jupyter Notebooks too, they allow you to mix not only text and code blocks, but different languages that you can specialize. Okay, I'm going to just write an SQL query and have that execute and get my data down. And now I'm going to pre-process it in R, and now this block is going to be in Python to run my machine learning model.
So would you use a tool like this to present it to other data engineers or to like business teams?
So,
You can use it for either, really. You can
Yeah.
use visualizations, documentation, and you can port it to HTML, put it up on a website. It's pretty nice.
Does Zeppelin also allow you to do that?
What?
Oh, does Zeppelin also allow you to export as a finished file?
Oh,
So I export this puppy and it just gives me a dirty JSON.
Oh, I see.
As opposed to regular dirty
So
JSON.
it's mostly for dev use and dev
Yeah.
work, not use for business. Okay.
I try not to let any business person touch any of my stuff unless it's hidden behind a shiny app.
Right.
Just saying. So we have that as our data. Fine. Come on. Woo. There we go. So we have template. And we can totally do a lot more here than just logistic. I promise you the speed issue matters at scale.
You are saying something about the pipeline, that using that pipeline is giving you performance benefits here?
It does at scale.
But this pipeline is
This is not a complete pipeline. So if I wanted to have it all in together, you know what, let's do that. So you want a complete pipeline? We will do a complete pipeline. Let's see here. Let's do okay. So let's copy this logistic regression. Okay, so all we need to do after this vector assembler is create a, how do we want to do this? So let's do, okay, so we have our LR model, and we can do, let's see. Oh, let's see. So, it broke. It's, yeah, I'd have to do it later. But, okay, so we have this. Okay. So we have that. This.
What do you mean by
I did not adequately research stuff because I was doing it on the fly. There's a way to do it, and yeah, Mr. Smiley over there knows there's a way to do it. It's just
I have never used Spark before.
this is on your to-do pile on Jira. So yeah, so there's that, and we have this. This is the by default gives out area under the ROC curve, but yeah, that was actually a serious problem because at one point we were using Amazon EMR, and EMR does not let you play deep down. This is EC2 if you look all the way up there, and yeah, I get to play with things. So get to that, and so I exported this out of PySpark and moved it back into R because R is much nicer to play with. And like all you get out of binary classification evaluator is area under ROC. This was really important. It was getting it to R so I could actually get a proper confusion matrix out. So that's just one flow, easy peasy.
So each step in the pipeline will be analogous to a function encasing data and changing in some way.
Yes.
So if that's the case, how is that different from MapReduce then? Because I remember when I was in school, like it would just be a function that's mapped to each operation. So from a programmer standpoint, it's pretty much the same
It's
thing.
just speed. Regrettably, I have no cooking for you.
So when you're doing MapReduce, everything it is saving in the disk, right? But when you are using this part, the individual steps it is saving in the number. So that's why it is. As you're saying in the first slide that it is
Okay.
10 times or.
So the storage unit is different than the
way there.
Well, I mean, compare against when you were in school versus today. RAM is much, much cheaper, yes?
Yeah.
Okay, so that is one workflow. There is really nothing outstanding in the pile of slides. I didn't warn that this was a total dumpster fire. Well, wait, where am I? There we go.
So I mean, other than being in memory, what else makes it fast? Why is it so much faster than any other?
If you want to get really hacky, you can do all of your user-defined functions and such in Scala. The JVM is also good stuff.
And you cannot do that with Hadoop?
I don't touch Hadoop.
Also, it has this, for example, all these functions, right? You can consider that way, that all the functions you want. It creates a logical plan. Sorry. It has like the concept of physical plan and logical plan. Okay. So from this logical plan, all the different combinations of the logical plan, it creates a physical plan that is optimized. So it does all this optimization based on logically because it doesn't execute that immediately, right? It executes when you are doing an action. So it can do all this optimization and it can create the best plan to execute the whole thing, all the things that you have in the process of pipeline. So at the end, you are kind of getting something very optimized that you cannot get using other platforms, for example, MapReduce, additional MapReduce. So these are the two things that's why.
So it's already built in, all this optimization, already built in Spark?
Yes, all this and
so
all
it has nothing to do
the
with the database, how it's indexed in a column base or row base. Just the way we're going to access that in the database and get it out.
database is completely different concept, right? Because this is simply a distributed processing framework, right?
So what makes it fast?
Okay. So basically, you're defining all the transformations you're going to do to your data set. Like these, and I'm going to group it, and then I'm going to project it this way, and I'm going to do all that. Instead of executing everything and each step putting in this and getting it back and doing something like this, you're just getting kind of your plan, what you're telling it, and defining, okay, if I do this first, it's going to be faster, and I do second this, and finds the best way of executing all those steps that you're telling it, and then only when needed, you will execute it. So in a way, you're kind of expressing what you want, and at a given point, it is executed the best in the optimal way. So that's better than MapReduce. Every step is map, send to this, reduce, send to this. And if you have many of those, then it's very expensive to keep going to this. So it's a combination of having memory and also just expressing what you want and not executing it right away, just being kind of lazy and allowing to them to see like the whole chain of steps and defining how to do it better. That's what you get as big. I'm not sure.
So it's faster because it will optimize the order of operations as long as whatever you told it to do with your data ends up happening, even if it's not the order you said.
Yes. In a simplistic way, yes. You need to know a little bit about it because sometimes you want to help it and say, yeah, at this point, catch these, do this, and so you get informed. So you can also kind of help them be more informed. But the main game is that things are not executed right away and sent to disk. You're kind of defining your plan, and then it's optimized. So similar to a SQL query that you do, you send it to the database engine, and it decides how better execute it. You don't need to tell it do this, use this index or this data. It will do it for you. It's a similar approach where you're just expressing what you want, and the platform will decide how to do it. For example, if you have a function that is adding 2, right? And for example, you are adding 2, subtracting 2, and adding 2, right? So you can just add 2 one time. You don't have to do all the 3 steps, right? If you use MapReduce, then MapReduce will do all these things one by one. But if you do Spark, you will just add one time and then you will not. That is the kind of automation we're talking about. That you have all these plans, and among these plans, you will choose the best.
Okay, so that I think covers that. As far as outstanding, let's see. So I have another Zeppelin notebook open, and I was trying to get the Enron data in here, and it I loaded it up, and there's wait, I think this minor debugging issue is actually taken care of. Let's see. Oh, okay. So I got all the way to the Spark data preparation step of this, and then I ran out of time. But speaking of lazy loading issue, it's great for speed, but then you wind up doing hacky things like forcing it to compute while you're debugging. So you get this, and then you get this, and then you get, hopefully, okay. So there's that. I don't know, I am mostly out of material unless you all want to play with text mining. I like playing with text mining.
How long do you
What?
The top place.
Tokenizer?
Yeah.
So the tokenizer totally failed.
How long did it take in Spark versus let's say if I did it on just R?
You know what? We can totally test out both.
Let's test it out.
I like that idea. I really like that idea. So we can, yeah. Or how do we do this?
How big is your data?
Let's check. Okay, so the email set is, let's count. Okay, gig and a half, give or take.
Okay, how long did it take? Let's see here.
Well, I still have to fix the indexer, but, well, here, so we can put it up with just whatever R command that would do that without going into Spark, and then we could try it again with the specific PySpark indexer. So it was giving me a null, well, it was giving me a null pointer issue because I was a disgusting hacky bum, and I did this with, let's see what their email scheme is. I just copied code for smooth cleaning, and it had a nasty little bug in it that, okay, so let's go through this. Boop, 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 boop. So this, yeah, gets that loaded up. So we have Enron data loaded in. It's going to take some time to load. See, this is perfect for checking your cell phone when, So this was the helper function that I totally copied. It originally said frozen set at some point, and frozen sets are bad. Frozen sets are very bad. Okay, so let's get that running. So there's that data preprocessing step, which this is going to take about 5 minutes.
Yeah, that's not bad.
Well,
It would have taken 20 minutes.
seriously? It would have taken 20 minutes in a while. That's how I burned out my laptop in undergrad. Yeah, so there's that, that's going. From there, I'm just going to create a data frame, and hopefully nothing breaks. So notice there's this little subtlety. This was, so from here all the way to here is, it's just using Python. That's all it is. When we get down into using Spark-specific functions is down here with Tokenizer, and well, let's go to documentations. So yeah, because I figured it'd be better than, well, this is the curse with dealing with Spark. You get spoiled by all these fast things, and then you have to go deal with things that you have to code by hand, and you're slow and boop. Where are we at? Where are we at?
So while this is going, I've got one more question, and then I'll stop.
I like questions. No, keep coming with questions.
So coming from like a web app development world, there's a lot of patterns that we talk about in order to manage code. You know, there's tons and tons of lines of code. We have MVC patterns, front controllers, blah blah, you know, so on and so forth, right? Is there anything like that in the Spark world?
What is an MVC?
Right. So I mean, it's just a way, it's just a principle to try to manage code better, right? But my question is, with the amount of lines of R code or Spark code, would it ever get to be unmanageable in the first place?
So in practice, like we've just been copy pasting stuff to GitHub.
Right.
With the work project, so
in the real world, you have like, you know, multiple files.
Yeah.
You know.
So work project with Spark, most recent one. Every single thing from the database was prepared separately, so that we weren't, you know, putting everything together and burning time like that. So there's data prep for stuff from one database, data prep for stuff from another, and it got out to 7 different files of just
So the
data
files
prep.
are organized according to what step you are in the process and the
Yes.
actual staging process.
And then from there, like the pipeline side, all I did were a bunch of joins, and then from there ran it through vector assembler and started modeling. So is that I am
I can
not
see that,
formally trained as a software engineer. I just crunch data.
So I have a,
Thanks.
Have you, I guess I'm just a little bit behind. Okay, so we have the data set is in a CSV, right?
Yes.
Okay, and Spark is running on your computer, or is it running in a VM, or is it running on a server?
I am running this on EC2. I posted the actual link to Zeppelin Notebook in Slack.
Okay. And what? So I'm a Google Services guy. So what is EC2? What is Amazon EC2?
Let me show you. So where is it? So you get to see my EC2 account. So I have a spot request running right now. And yeah, all I did to get this going, so come on. For sorted tasks, I just go ahead and build an Amazon machine image and get everything I want in there. And then I save the image and then launch it back up again. So, like the instance this one was built on was from forever ago, and I was trying to get Spark TensorFlow on Spark to work, and that like the Enron data is already in there from that project. EC2 is the breaker of Amazon services. I am not exactly pimping Amazon, but EC2 is you rent computers. You have your hand raised.
I mean, going back to your what question I had was suppose, for example, you are doing text mining here, right? I mean, this code is going to work fine when where does just a couple of emails or what I mean to say, less amount of data. When we have 1 TB and TBs and petabytes of data, what my question is, if we go for Hadoop, I understand the operations part that we have to call the data nodes, we have to call the nodes to fetch data, and that's why it is lower than Spark. But again, there is a reason why we don't keep our data in RAM. There are reasons why we don't prefer RAM. So how does Spark handle that? I mean, if we have, for example, if I'm doing text mining or Twitter tweets, we are getting 4K. How would Spark take that into consideration? Hadoop, I know that we have distributed data, the data would be there in those systems, I would fetch. But if considering Spark, if we take RAM into consideration, how would it fetch that amount of data in its RAM and process? I mean, that's
it
really.
doesn't. So when you say fetch, you're talking.
I'm struggling to understand the processing difference between Spark and MapReduce when it comes to huge amount of data. Huge means petabytes of data. I am struggling very hard to understand how I mean processing time, calling nodes and all, I can understand it be a little faster, but when we say that Spark is 100 times faster than what MapReduce does.
It's only 100 times faster when you can get everything to rank. Of course, if you set up your database really beautifully to where you have enough on your individual nodes to where you have enough RAM to cover it, you're in the clear.
So should I conclude that it is not for huge amount of data? Is that something?
What?
I mean,
So let's talk database structures. So you've got, we have our master node, and we have 1, 2. So you brought up, say, 1 petabyte. That works out to how many nodes?
I mean, if we say, for example, if you take 100 nodes and replication plus 3, so 300 nodes, for example.
So 300 nodes.
Yeah.
So, okay. And each one of those, that's what, a terabyte of data?
Yeah. So yeah.
Okay. How?
So the question is, why are you keeping your input data? For example, if you use MapReduce, right? Why you are keeping your input data?
So that is going to be one node which is going to do the processing, right? I mean,
No. One node is
call the other node is what I'm
So
saying.
this is the thing. So MapReduce, Hadoop, or Spark, whatever you say, these are basically distributed processing engines, right? But you have to keep your data somewhere. So from where you will read your data, and then you will process your data, and then you generate your output, and then you will write your output to somewhere, right? So for example, you can use HDFS, right? For example, you can use Hadoop, and you can use HDFS to keep your input data, right? And your Hadoop system, ecosystem will read the data from HDFS, and it will do all this complex processing, and then it can write the data in your HDFS, right? Similar here in Spark, you can keep your data in HDFS, for example, petabytes or whatever data you have there, and all these nodes that are working as workers, they will go with the HDFS data store, and they will test this data, and they will do the processing, and finally you can write this data again in HDFS, right? So all the differences that we are talking about considering Hadoop and Spark is that when the processing will happen, what is the impact of these hardware resources that you have? For example, you have RAM and CPU, RAM and hard disk, right? So what is the impact of these hardware resources when you are using Hadoop and when you are using Spark? So
Okay,
it
correct.
is,
I mean,
yeah.
I 100% agree with what you're saying. So that is the case when you do interaction between the databases and the nodes. For example, I don't have to traverse through Teradata, SQL. I don't want to go anywhere. I use Hive, which is big data. I mean, I can connect to HBase directly through Hive.
Yeah.
That means I am reducing some of my interaction, correct? So
No. This is the thing. So when you are using Hive, what is happening? You have your data, right? And Hive is nothing but it is using MapReduce, right?
yeah.
So
Yeah.
the processing is happening in your distributed processing framework, MapReduce framework, right? But you have your data somewhere. That is what you are talking about.
Yeah.
Like where you are getting your data.
I mean, it is going to be the RAM.
That is all about like boils down to the simple point like how your processing will happen. Like it is all about processing. It's not about where you are keeping your data or where you are writing your data, right?
So is it the only processing time of the interaction between the nodes or something?
No, it's like how you see like if you process everything like taking the data from there, it will be much faster, right? So what your Hadoop will do? It will try to keep the data, whatever intermediate things it is doing, it will keep just things in right? Disk. And disk access is very costly, right? You have to like you read the data from disk and then intermediate steps you have to save the data in the disk, right? Rather than doing this thing, if you just read the data from your RAM and also write the data in the RAM, and finally you are writing the same place, for example, HDFS or whatever data you are talking about, right? So it's like this intermediate steps is we are talking about this processing. That is much faster than like.
One of the key points is that in Hadoop, you're storing all the intermediate steps. So if something fails, you go to the last thing you store. With Spark, because you have your recipe, you have the steps that you do, and you optimize it. If it fails, you go from the very beginning, you just execute those steps, you get to the final thing. So you kind of partition your data in all these different partitions, and let's say 4 out of your 5 partitions are fine, the 5th one fails, so you only repeat the steps for this 5th one. You get the final thing, and then you reduce at the end. It's just a computational engine. It doesn't care where you store it. It's just how you execute these transformations you've done.
Thank you.
more in machine learning aspect of this product. So can you, if we forget about the data, which is not possible, can you compare the predictive modeling functionality of H2O and Spark?
I would probably say that they're equivalent. For anything that people are going on about being really exciting these days, everybody is excited about deep learning, and neither of them do a fantastic job. So there are implementations that people are playing with, but other than that, yeah, I'd say it's half and half equivalent.
Does that mean, for example, you run extreme gradient boosting or something like this, and you have all this functionality to tune the ensembles and to make whatever you want with the random forest or all this stuff, and at the end you receive executable line that you can run on the data?
That's having a difficult time parsing what you're looking for. Frameworks are frameworks.
Well,
They are both in
I'm looking for the most important thing at the end. The most important thing for me is the accuracy of the model.
That's
and not only
not,
for me, for the clients. So at least
that
in my
is not
world.
that is not a Spark versus H2O versus anything issue. It's a how you choose to go about modeling these things.
But if you have large amount of data, how can you expect that your model will work in just that if you cannot train them? Right? So if you have a lot of data, right? If you don't think
You never do one model for the entire data set, except with the beginner. You start looking for clusters, split the data, and then do models.
No, what I'm saying is that if you have a lot of data, right? More data is good for machine learning model, right?
Not always.
Most of it.
Okay.
So if you cannot process that amount of data using the underlying infrastructure you're talking about, right? Then the benefits you will be getting in the accuracy is based on your infrastructure, right? So what's the point? My point is that given the highest processing power, you can obtain better accuracy. For example, this is the thing I'm talking about.
If you know what you're doing, and if you don't know what you are doing exactly, because when you have 5,000 attributes and there are 70% of them are sparse, and you have to combine them in some way so to extract the useful information, but you are afraid because they are so sparse that you cannot rely 100% on the data. It's illusion that the data is big. Usually, especially in the area where I have been more working in this area of healthcare analytics, you have 1,000 variables and only 15-20% actually are normal. Everything else is so sparse. And these are the most important ones. So processing power is going to help me only with one, which means the best tool for now to find patterns, which is association rules. It's very stupid, it's very simple, but it works.
But okay, consider the number of pixels, right? You were saying like 15 of the pixels they are kind of evolving, right? So after considering these 15 features, right? You have 100 gigabytes of data you are getting, right? And the infrastructure you have, you can only handle 2 gigabytes of data. What do you do now?
I don't care about it.
No, you don't
That's
care
not
about
my
it,
job.
right?
It's the job of data science or data engineers, but I said we respect them very much. I want to build as good as possible model. Fast, it doesn't matter whether I train the model 1 day or 3 days. At the end, after the model will work next 6 months. More important is model to be as tuned as possible, using all potential anti-stupidity steps to reduce future noise.
No,
So that's why I'm interested in advantages.
I disagree a little bit because you have your
You
model,
can disagree
right?
how much you want, but that's the right.
Another thing I just want to point out is that you have to train your models regularly, right? You cannot just because the data is changing. Every day,
That's
new
that's
type of
true.
data is
Each quarter, yeah, each quarter.
even though you have the models, you have to basically get all these hyperparameters from your data that you're continuously getting every day, right? So if you don't have the ability to process all this data that you are getting every day, then the infrastructure is a big issue for you. It's not
Well,
only
we
that.
usually don't process all data. We usually process only very sensitive clusters. Because in the rest of them, it doesn't matter what is the
Yeah, it
accuracy.
doesn't matter. Even
It's
that,
not going
that
to
amount of
influence
data
the
you are
law.
considering that might be big, right? Just consider like you have thousands of attributes and you are
So
considering
I'm a
only
little
two.
bit confused. Again, what's your point?
My point is that in order to achieve good accuracy, you need to have a good processing, right? Given that you have a very like big data set and your data is already coming in. That's the thing of what I
Well, only if you use all subset solutions, which means you want Jesus to analyze all potential models and to tell you this is the model. And then you run millions and millions and millions of models. But you assuming you are not Jesus, then you kind of limit yourself within models that you believe from the literature are working.
Yeah,
So nobody
How
wants
do
to
we
build
feel about doing
Sorry.
this high dimensional debate, say, for another meetup? Because you're right, the high dimensionality issue is it's
Okay.
important. It's a big deal. Yeah, but like, I don't. Your point about infrastructure versus modeling processing, most of what you just said is a data preparation issue. Yes. Yeah, that's and we have data preparation tools in Spark to some extent. But if you're chasing it at that level, yeah, you're going to have. You and I both know darn well you're going to have to get in with.
It's not only data preparation issue. I agree that it's mainly data preparation. But for example, a very close friend of mine recently called me a kind of a little bit urgent question. There is a difference between the accuracy of gradient boosting in R and gradient boosting in Python. And he made this analysis kind of a week with many data sets. And if he has clients for more than 500 million, then he must be accurate. So accuracy is what matters.
But you guys are saying the same thing. But what we're saying is if you have a lot of data, and if you don't have the capacity, I'm sitting in my laptop, what do? I sample it, correct? I say just 20% of that data, and I run my model.
But if you
And then if I
have
want to be crazy, I'll sample it again, and I'll run the model. I want to be crazy, I'll sample, but my computer cannot handle the amount of data. So what he's saying to you is like, instead of you sampling and just getting a little bit and putting your model, you can run the whole thing, and that's what he's trying to say.
But that's already available in the software. I'm sorry. That's already available in H2O.
Exactly.
It makes sampling for you.
So that's again, it becomes a preference. It becomes a preference. You want one that do it at one time, use all the data. Hey, I'm gonna take all that data and which what I'm understanding from Spark, I don't know Spark. Let me run my model with this whole chunk of thing. Like let's say you have how many attributes is in that? You gotta run a background
5,000,
thing
8,000.
to get the best correlated variables. So I say, oh, I'm gonna narrow it down to 20 variables, but that takes time. When I do it on my laptop, it takes forever. So I sample. I'm gonna take 10%, I'll take 20%. But in this case, in Spark, you don't have to do that.
And also regarding
So I'm thinking.
also regarding this data processing, right? So you are kind of thinking that all the features are there, right? But if you think that if you have like raw level event data, then you have to basically make all these features, right?
Yep.
For example, if you consider like how many people went to Amazon in a day, and you want to capture their frequency, but probably you want to take 5 of them given the 1,000 times they went to that website, right? So these type of complex features, you need whole days of data Amazon website, and from there you can build these features, right? Unless you have a solid infrastructure, how can you build these features? You cannot even go to the model, let alone this like so you have this data preparation that is used like you will struggle there, even before going to model. Because if you don't have the feature, you don't have the model. Right?
And what he was trying to tell you is he has techniques that can do that by sampling and getting the score.
But it's not all the time you can sample, because the type of data you are getting, you cannot sample, right?
Again,
Right.
it works.
So let's move on from
I'm sorry, one more question. Is there a comparison in the speed of whatever, Spark and some other software when you have something that you cannot differentiate and you cannot optimize, and you have to do some kind of optimization language, maybe even heuristical one or something like this. So in the case that this works significantly faster, as you mentioned, then I see advantages in this direction because many data science is, in my opinion, avoid a complicated procedure which require a lot of optimization if the data is very big. So just from computer standpoint.
I mean, if we were going to be super anal about performance standpoints, then I would go back to the freaking high-performance computing days involving doing things in Fortran. You have to balance the programmer time versus computer time, and I think Spark and Scala is an appropriate compromise. This isn't, doing molecular dynamics.
So if I'm, this is kind of a softball question for you. If I'm interested in learning more about Spark, what would be the next step for me after I read this?
So, books. I don't actually recommend any of the intro books on it. However, this one is good. It's a bit hacky and nitpicky, but chapter 9 at the end, where it gets into everything about Spark ML, highly recommend. It's actually worth the $22 for the just the Spark ML section. And yeah, this is where I recommend going next.
The tutorials that they have on the front of the website are great for just getting started.
Right.
That's where you should start.
Okay.
Well, there's 3 or 4 really good ones. Just walk through them because it sounds like, for a lot of people asking questions, you don't even know why you would want Spark, what it's going to do for you. So that's where you start. See the samples for how Spark is saying this is what we're good at.
Like this example here was possibly the most trivial one I could have created. Yeah, and it's basically on par with whatever you just described as being welcome to Spark.
Okay, thank you.
Yeah, so I just want to know, we have one more machine learning framework called scikit-learn. And
What?
then, scikit-learn, sklearn.
Oh, sklearn.
Yeah. So it's like Python machine learning, library, framework, you could say. So they have lots of models. So if you want to do machine learning Spark, so do we have to always use the Spark ML, or we can use it under machine learning model also?
So how hacky do you want to get? Yes, you need to use Spark ML tools to leverage the power of Spark. With that said, if you want to get into the weeds, you can, dust off the Scala book and implement your own functions in there, and then run it distributed like that.
Also, to answer your question, so this Python library, scikit-learn, right? So these Spark guys, they are basically all the functionalities that it provides. They are giving all the functionalities that we have already given. So if you are familiar with that one, you will find it very easy because all the commands are the same, and it's like you don't have to worry about it because then you can consider it you already know. You just have to know how you can describe it. Because we are kind of one-to-one. We are just taking all the libraries and just formatting it because they said that is the most popular language nowadays, so they do not want to reinvent the wheel and do not want to try new types of things. So that's why they just copy this for it.
And one more question is so we have different choice of languages when we use Spark. So most of people say that Scala should be the best language to use Spark because Python is high level API. So is there any what is difference if I want to code in production? So what should be the language of choice? Should I go with Python or should I go with Scala?
I have my biases. I like Scala. I like R. I use Python because I have to. You can also get into the JVM directly with Java on this.
Does language matter a lot? If you're
everything comes out fastest with Scala on Spark.
It matters because you see, this is the native language, Scala, and the Spark is the API, right?
So if you use Scala, that is the fastest one, right? If you use PySpark and if you use DataFrame, then you can get similar performance if you consider Scala. But if you don't use DataFrame, for example, if you use RDB, then in Spark is totally screwed because they have this time step. They say, for example, from one step to another step, they compress the data, right? And they go to the next step. So if you use RDB in Python, then this time step is not available here. That's why performance is very slow. So if you can do a quick Google search, you can see all these performances. So basically the idea is that if you can use PySpark as long as you are using the data, then your performance is really up to par compared to this. But frankly speaking, Scala is the best one to use.
So is that talking about data frame, are these the standard data frame you are talking about?
It's like similar concept, and they are kind of taking all these ideas that they are already Python people are using, and they are taking these ideas and just importing those things in this part, so that it's like people do not need to like plan.
Please babble about sklearn. I know you're gonna love babbling about sklearn.
Is it better to implement training a machine learning model as embedded in the pipeline if you're not going to use the Spark ML libraries, or is it better to use Spark as a pre-processing tool to create the data and then load it into a separate program outside of the pipeline?
If everything you want to do can be done in Spark, do it in Spark. Obviously, power users are going to run into a point where they want to do more than is currently implemented in Spark.
Corollary, if you do use Spark ML as your final modeling, what formats does it export the models, and are there ways that you can have it export in specific formats that are definitely going to work with other languages?
Okay, so this is why I like obsessively check B types on things. Let me pull up an example. How do I keep my hand on mine? Okay, so where's B types? I have B types floating around here somewhere, but it's highly important. In order to export to CSV, like you can't have this vector exported to CSV. You can, I believe, do it into JSON or a Parquet file though. Like production at work, well, it's not production, but everything there is saved in Parquet. For export, at least coming out of my end, it's saved in Parquet. When you move between Spark to something else, I always like a CSV. I understand that there are those of you that like your JSONs, and there's a special place in hell for you. Now, is that sufficient?
Yeah.
Okay. I am exhausted. Let's somebody so because this is a beautiful Zeppelin notebook, we can do parallel programming without running around decapitated chickens. Oh, Casey, where'd you go? So yeah, there's this debugging step that still needs to be done on the text mining, but I am pretty spent. I'm guessing you all are yeah. I don't know. You all decide what you want to do. Let's take a break.
Yeah, it is 8:17 right now. I can stop the live stream. We can either take a break or we can break, and anyone who wants to stay around can ask questions, because there's a lot of really smart people in this room, and a lot of people will have a lot of questions.
Yeah, that's
Great.
Sorry about that. You said there's a special place in hell for Python users.
I said
JSON.
Same thing. What's the difference? Joyce, it's the same programming language. Json is the same programming language.
The problem with Json is that it makes it really hard for me to work with. Because I have to unnest it.
So my degree is in statistics, and I also did more, and I did molecular dynamics.
Does R use the
No, it is nothing. So there
See
is
that big R there?
Spark
That's
R
actually mine.
API.
I'm in charge
So
of
maybe
R
go use
but it's open to everybody. It's open to everybody, so I can actually make enough parts that are users.
Yeah, no, it's probably right there.
We're gonna start the beginner's workshop. It's gonna be based on. It's not gonna go straight into data. Well, it is data science, but it's not gonna go into machine learning right away.
I don't care about machine learning.
But we're gonna start a workshop very soon based on this book, which is the tiny
Well, I
curves.
have one another which is
But this is the new syntax, because R is a new open source.
yeah.
So everybody puts their hand in there.
This is going to be a course, right?
I'm gonna be giving a course, yes.
Okay,
And
so
so you're going to start from what?
Probably in 2 weeks
Okay,
from
so
the
yeah,
beginning
this
from
goes straight to my
scratch. Somebody who doesn't know anything.
So should I look
Beginners. No, because guys. No, everybody's invited. What we're trying to do with our ladies is to just be a role model for girls, so they can get into tech. That's all.
Where is going to be the course?
We are actually going to move to code school. Find me on Meetup here. You know what?
Okay, I'm going to give you something.
I'm going to be doing beginners workshop. Probably I'm going to start in 2 weeks.
You know what? Let me see. Okay.
You find. So the only thing they know.
what? Casey said she would be back around 8:30.
The only thing you're not allowed to be is an organizer. But you're not. I am an organizer. Sorry.
Tell me your phone.
Here, I'll give it my
Oh, it's probably
407. 407. 430.
well, that's where she does like she's had a meet up there. I know, I haven't gone.
And my name.
I don't know. We'll see her in view. They were wrong. No, I don't. I've never used names that big enough to need.
So you put OGI. And I have to your name is
Today was like luckily my day off, but I spent most of the day working with this data. Actually, like I was gonna have to do Michael or even easy. I'm working with this data set that has unique identifiers on certain files.
I'm gonna go ahead and put R.
And okay, remember last time you told me about
Like find me on Meetup. If you go to Meetup,
remember
find
that?
me
Okay,
on
like I went and I like read about it.
so you
And
can
I
see
was like,
what
oh,
the
this is
perfect.
perfect.
And I can, if you send me this, I can add you.
Well, this was like a very good
So where are you from?
example of like how I can use it. Because for example, like I have all these like unique
I
IDs
didn't have from Bulgaria.
for people, and then unique IDs for schools, and unique IDs for.
So you go to Meetups.
So like the person can have
Member.
multiple degrees.
That's
Cool.
so you go in.
Okay.
All it is
like literally the
is
whole
it's
day I'm
open
like,
to
okay,
everybody.
I can
The only
clean this
thing
up a
is
little
you
bit.
cannot be organizer, which again it's me. But it's open to everybody, and we're just gonna try to bring presenters that are open to it.
And then besides that, I've gotten to the point where I kind of
Where do you work now?
Oh, well, there was a company.
yeah. So like let's do
And after that, after that, Elsevier bought the stuff, I wanted to mention, companies, so
there's more. I got I think like 10
and
files.
it was disaster because from small company where I want a new model, I say like this, and as opposed to concepting. Well, that's not in the roadmap. I think that's
So
that's important.
you can have a
I think they have to do this now.
So now why would you want to learn art?
Like there's no,
Because
you can't have two person.
Because
But person can be related to multiple schools.
it's not as rich as
Right? So like eventually, after I join everyone, we're gonna pull out the highest level agreement that person has. So then I really only one identifier for each of these categories. They're only gonna have either
the back
bachelor's, master's,
junk.
as their grades.
Yeah.
Junk that you
But for now, when I'm trying to join these,
So
we have
By everyone, I hope the text wasn't too small.
right.